Okay, just like this whole series of videos, guys, I just want to remind you that, yes, this is part of the beginning of first semester, but because of that, this is a video you're going to want to save and study also in the future, let's say a couple of months from now, because this material will be on our first semester final. So let's get going here. So what is one of the things we need to learn, and it'll take us time, okay, is we got to get better at looking at graphs and analyzing them. And what do we want to do is focus on key features. For example, they're asking for the x-intercept here. Well, notice it crosses right here the y-intercept. Getting ahead of myself here. That's called the y-intercept because it crosses y, but it also crosses here and here for our x-axis, right? So where it crosses x is the x-intercepts. So these are x-ints, okay? And of course, where it crosses the y-axis down here is the y-intercept. So my grid lines are not quite showing right, but I think if we were to approximate, oh, I wish my grid line showed up a little bit better, but you're going to have to guesstimate sometimes. So I'm going to guesstimate that one, since my grid lines are so terrible, I'm going to guesstimate that one's probably around 2.10, or I should say negative, don't forget, left is negative, so that'll be negative 2.10. Now again, I don't have the grids there, but I'm just guessing 1, 2, a little bit past 2, around 2.1 or so. On this side, let's see here, 1, 2, 3. It looks like it's between 4 and 5. So let's say I also guess it to be 4.50, 4.3, 4.40, somewhere around there. Down here, this is going to be our y-intercept. Y-in is short for y-intercept. So I'm going to say that's a little bit maybe past 6 or about 6. So I'm going to say 0, negative 6. Now remember, because I'm going down, that right there, for example, is negative 5. So I'm going to approximate that to be negative 6. Right there, I'm talking about where the intercept is. Now the domain for any quadratic is, notice it goes up forever on the right or left, but that means I can put in any x value and it's going to work, right? So we would say our domain goes from negative infinity to positive infinity. That's a way of saying all real numbers work. All real numbers work. And the range are your y's. Now for the y's, notice the graph goes, the lowest it goes is right there. So again, looks like I'm going to have to guesstimate, but I'm going to say that value there, let's say, is at negative 1, negative 7. I'm going to assume it's matching up here and there. Okay, again, I could be a little bit off with my numbers because my grids are off. But if that's the case, I would say my range, remember my y, the lowest it goes is 7. So I would say my range is, it's going to be from negative 7 up to positive infinity. We also could say y is greater than negative 7 or equal to, assuming that vertex right there is at negative 7. Okay. Now the average rate of change is simply a way of doing slope. Okay. I'm going to address that later on in this video if I have time, but that's the one thing I'm worried about I may not get to. Let's keep going. So that kind of gives you an idea how to do that problem. Now, let's get to the graphs. Remember, you can make a little table to help you with the graph, but whatever value, look at my absolute value part, whatever value in here makes it 0. In this case, 3 is going to be part of your vertex. So 3, 2, always take whatever makes it 0 with a number at the end. So I know that 3, 2 is my vertex. So I'm just going to graph 3, 2, which is right there. Now, the number in front here, sometimes referred to as the A, you forgot the negative right there, whoever did this, okay? because it's -2 means I know it's going to have a slope of down 2 on each side. So I'm going to start at my vertex here, and I'm just going to go down 1, 2, and I'm just going to go over 1 in each direction. The key thing is I had to go down 2 and over 1 each time, and so I'm going to get a graph just like that. Let's look at the next graph. This time, notice right here, -1 plus this 1 would make it 0. So taking that and that value, this is going to be my vertex. So I'm going to go to -1, -4. The only thing else I have to do again is look right here. I notice that's a +3. Now positive means I'm going up. So I'm going to actually go up 3. So starting here, I'm going to go 1, 2, 3, up, not down, right? Because it's positive. And then I'm just going to slide 1 to the right and 1 space to the left. And if I just connect it, I have my graph. Okay, on this one here, again, notice that this is a quadratic, but I'm going to start exactly the same way. I notice right in there that -2 would make it 0. So I'm going to take -2 and 3. I know that's my vertex. So -2, 3 is right there. And now what? Well, because it's a quadratic, I actually need to make a little table or think of it as such. I already know that -2, 3 is my vertex, and I need at least 1 point below and 1 point above it to get the left and right side of my vertex. So if I plug in -1, that's 1 more than -2, right, into here, I get this. Now, -1 plus 2 is 1, squared is 1. There's this negative in front, so I get -1 plus 3, which is a 2. Now, by symmetry, this also is going to be a 2. So then I can just go -1, 2, -3, 2. It's going to curve downward this way, and there's your graph. Okay, let's try one more graph. We're going to start by finding our 0, right? -1 plus 1 is 0. So I'm going to combine that with the n number there. -1, -3. By the way, we call this our h and k values. In the next video, you'll see me reference that. But this is my vertex. So I'm going to go to -1, -3 right there. Now, because my vertex is at -1, how about we pick a point that's just one place to the right, which will be 0. If I plug in 0, 0 plus 1 is 1, squared is 1, so I got 2 times 1 minus 3, 2 minus 3 is 1. So I now know, look at my table here, guys, that 0 is 1, -1 is -3, -2 will also be 1. This and this will match because of symmetry. So I'm going to go to 0, 1. I'm going to go to -2, 1. Starting with the vertex, I know it's going to curve up like that and curve up like that. Finally, we're going to go to this last problem. So the one thing I'm not teaching you is average rate of change because of the length of the video. I'm going to stop it there. So that's maybe one thing that you'll miss, but we will make sure we teach that in class. Okay, unfortunately, you're going to miss it in the video. But they're asking for the x-intercept. Notice it crosses right there and right there. Again, I have to guesstimate, but that's -1, -2. So this time I'm going to say it's at -2.30. And here, it looks like, oh, wait a minute. Yeah, I just want to make sure I'm looking at it right. So this is +1, so I'm going to guesstimate that at, let's say, 0.50. Now, again, unless your teacher makes sure he or she gives you good graphs, guys. If you guesstimate, I think you'll be okay. All right. Now, speaking of y-intercept, it looks like our y, see how it crosses right here? This is our y-axis, right? And if my grids are correct, this looks like here, this is -1. So I'm pretty confident my y-intercept's at 0, -1. Don't have to guesstimate there. What about domain? Remember, that's going to be -infinity to positive infinity. Another way of saying x is all real numbers. Because I can basically plug in any x I want. That's what domain is, guys. Domain is what x's can I plug in to my function. I can plug in any negative, any positive number. It's going to be somewhere on this graph, right? Finally, I'm going to do range here, guys. Range is your y. Now, do we have to guesstimate this one? Because it looks like maybe that's -2 there, right? So it looks like my vertex is at -1, -2. So therefore, since my vertex is at -1, -2, the lowest that it goes in the y direction is -2. Range are your y values. What can your y values be? Well, in this case, y has to be greater than or equal to -2, or as we say, it goes from -2 to positive infinity. And hopefully this video makes sense, guys. Sorry I ran out of time to do average rate of change. That's something I will have to address in class. But at least you have everything else pretty well done, I'm hoping anyways. See you around.